Okay, so I know some of you are still struggling a little bit with compound interest. So what I've done is put together 4 word exercises here that we can use to rehearse this a little bit. So let's take a look at the first one here. So we have Stacy took out a 4-year loan for $19,250 to purchase a car. The annual interest rate on the loan is 6.99% to be compounded monthly. What was the total cost of purchasing the car? Okay. Now, the first thing we want to do before we do anything else is figure out which of the 3 formulas we're going to use here. So, what we're doing is we're looking for particular words. And in this case, the word that jumps out at me is compounded right here. That's a dead giveaway. Excuse me. That's a dead giveaway that we're dealing with our compound interest formula. So let's remember that the compound interest formula is A equals principal times the quantity, 1 plus R over N raised to the N times T power. Okay, so let's review for a minute what each of these variables represents. So A, this is going to be our total future value. Whoops. Or in the case of a loan, it's going to be the total repayment amount. Now, in both cases, I want you to notice that we're talking about total, all right? The total future value, the total repayment amount. And we'll talk a little bit more about this in a minute. Our P that variable represents the amount borrowed or invested. And recall that this is the initial amount. All right. Our R, this represents our interest rate. And that's going to be our number that's attached to that interest rate symbol, the percent sign. Now, we can't just enter this the way it's written. For purposes of our formula here, we need to convert this to a decimal. So the easiest way to remember how to do this, if you're not sure already, is to take the letters D and P and write them in alphabetical order. Decimal, percent. If we're in decimal and we want to get to percent, we're going to shift our decimal place to the right. If we're in percent, which is what we are here, but we want to get back to decimal, we're going to shift our decimal point to the left. In either case, it will always be 2 places. Always, always, always 2 places. Why 2 places? Well, let's talk about what this percent sign really means. So, okay, if we look at this, can you see that this actually looks maybe a little bit like a division symbol that's been kicked over on its side? So this is our division symbol. And do you see the similarities? So really, percent means that we're actually dividing by something. Now, what are we dividing by? Well, let's look back at our percent symbol. Do you see maybe that there's a 1 there and a couple of zeros? Well, percent literally means we are dividing by 100. Dividing by 100. So if we divide by 100, those 2 zeros tell us that when we shift our decimal place, it's going to move 2 places. Let's do a simple exercise and prove that. Let's say we have 100 times 3, right? So normally, this number 3, we understand the decimal to be immediately to the right of the 3. So when I multiply this out, well, 3 times 0 gives me 0. 3 times another 0 gives me 0. 3 times 1 gives me 3. And the decimal place still resides all the way to the right. So what happened? When I multiplied by 100, my decimal point simply shifted 2 places to the right. Well, this exact same idea is what's happening when we convert from percent back to decimal, except that rather than multiplying by 3, we're dividing by 3. So division, being the opposite of multiplication, reverses that process. So instead of going to the right, we're going to go to the left. All right. So when we enter our interest rate, we're going to convert this. We're going to shift our decimal point 2 places to the left. So we're actually going to enter 0.0699. Now, I want to talk just for a second about this leading 0. Now, mathematically speaking, it's not necessary. You could enter this as simply 0.0699, and that would be legal. However, those of you who are going into healthcare, in the state of Michigan, and I suspect other states as well, that leading 0 is actually required by law when you're documenting medication dosages, things of that nature. That leading 0 is required by law. So I want you to get in the habit of using it. Even if you're not going into healthcare, it's not going to hurt you to use it. I just want you to get in that habit. All right. So enough of that. T. All right. This is the one that tends to give students nosebleeds. It's important to remember that our T variable is always, and I can't emphasize that enough, it's always entered in terms of years or fractions of a year. So always entered in terms of years or fractions of a year. Now in this case, if we look back up at our exercise here, it's telling us that this is just straight up 4 years. So because T is always entered in terms of years, well, that's just going to be 4 years. And then now the other variable is going to be our N. This is another one that tends to give students nosebleeds. So our N variable N is the number of compounding periods in 1 year. N is the number of compounding periods in 1 year. So our exercise told us that this is gonna be compounded monthly. So if it's compounded monthly, how many times per year are we compounding? Yeah, 12 months in the year. So that means we're gonna compound 12 times. All right. So if you want to get this in your notes, go ahead and pause the video. Otherwise, I am just going to continue moving on. So our formula once again is A equals P times the quantity 1 plus R over N raised to the NT power. All right. So now what we need to do is we need to start entering all this stuff into our calculator. Pardon me. So in this case, A is our unknown. That's the total cost. Remember we said that A is the total future value or total repayment amount. So that is our A amount, our A value. So we don't know what that is yet. So what we do know is all of this stuff. So our principal, the P value, is 19,250 times the quantity, 1, plus R, remember, is 0.0699 divided by our N, which we said is the number of compoundings per year. That's going to be 12. And then our exponent, pardon me, is going to be N, which of course is still 12, times T. And T, we said, in this case, was 4. Now, if you want, this is a simple enough expression that we could calculate this in our heads, and we could simply write 48. That's perfectly fine. But as you'll see in some of the exercises coming up, you're going to have combinations of numbers that aren't going to play so nicely. So you may want to just go ahead and leave it in the expression form rather than trying to grind it out. Now, this is what we're going to enter into our calculator. So I'm going to come over here, turn on my calculator. So we're going to enter $19,250 times the quantity 1 plus 0.0699 divided by 12. Now we're going to close our parentheses. To access the exponent, we'll use this little caret button right here. Let me draw a circle around that. We'll use this little caret button right here. That's going to get us into our exponent mode. And then we'll just enter 48. Now notice I didn't include parentheses here. When it's just a single number, you don't need them. If you have an expression inside, or if your exponent component here, exponent component, it sounds like a Schoolhouse Rock. Exponent component. Oh, never mind. Sorry. I just totally lost my train of thought. If your exponent part here is an expression. So something multiplied by something divided by something, it's probably a good idea to include your parentheses. So once we've entered all this, we can hit the enter button, and then we are going to get this result of $25,439. And usually when we're dealing with financial stuff, we're just going to round to the nearest cent. So in this case, we would have 42 cents. So the total cost of purchasing the car was $25,439.42. All right. Moving on, let's go to our next illustration here. All right. So moving forward, I'm not going to be spending as much time in all the details of what the variables mean, because if you need to see that, you can rewind to the previous example. So Devontae invested $2,953 into a certificate of deposit that pays 3.75% annual interest to be compounded quarterly. What will his investment be worth after 45 months? All right. So once again, we're going to try to figure out which formula we're going to use. And so we look through this and we look for those certain keywords, and there it is right there, compounded. That's your clue that we're going to be using our compound interest formula. And once again, that is this guy. All right. So the next thing you want to do is let's list out our variables. And what I'd like you to do at this point is I want you to go through this, pause the video, go through this, and see if you can figure out what's going to go where and what it's going to look like. So pause the video, give that a try, and then I'll join you on the other side. Okay, so let's compare notes. Our principal amount, well, that's going to be our 2,953. Our rate is going to be 0.0375. Our N, because we're compounding quarterly, and there are four quarters in a year, that's going to be 4. Time, this one might have given you a little bit of a struggle. So remember we said that our T variable is always expressed in years or fractions of a year, but they gave it to us in months. So what we're going to have to do is somehow come up with a way to convert this into years. The easiest way to do it is just to take the number of months it's given us and simply divide by 12. Now, you don't have to reduce this for our purposes here, because we're going to be dumping all this into our calculator anyway. Let the calculator do the heavy lifting. So we're going to use T, or T is going to be 45 divided by 12. All right. So now, go ahead and enter it into your calculator and pause the video while you do that. And then I'll show you what it looks like in my calculator window over here. So go ahead and pause the video and enter all this into your calculator. All right, so I'm going to enter 2,953, 1 plus 0.0375 divided by 4, close our parentheses, and then we're going to have n, let me back up, n times 45 divided by 12. Now this is what I meant. This is what I meant when I said if you have an expression for your exponent, just go ahead and enter it. Don't waste time trying to convert it. Let the calculator do that for you. All right, so this is what it looks like when I entered it. So let's hit the enter button and see what we get. All right, so we get $3,396, and once we account for rounding, 66 cents. So this is what his investment will be worth after 45 months. Now that's just a little bit short of 4 years. All right. Cool deal. Moving on. All right. Minji wants to set aside money for her daughter's future education. When her daughter was born, she and her parents invested $4,595 into an annuity that pays 5.93% annual interest, compounded monthly. Now, this is a two-part question. How much will the annuity be worth after 18 years? And part B, how much interest will her principal have earned? All right, so I'm gonna pause here. I want you to pause the video, and I want you to decide which formula we're going to use, and I want you to set up all your variables. So go ahead and do that. All right, so I decided, looking at this, well, there's our keyword, compounded. So we're going to be using our compound interest formula. And once again, that's A equals P times the quantity, 1 plus R over N to the NT. And our variables, we have our P, that's going to be the 4,595. We have the R variable is going to be 0.0593. Our N, we're compounding monthly. Once again, there's 12 months in a year. And our time, well, this gives it to us in straight up years. So this will just be 18 years. Okay. If you haven't already, go ahead and pause the video, enter this into your calculator, and then I'll catch you on the other side and I'll do the same thing. All right, so we're going to have 4,595 times the quantity 1 plus 0.0595, 593. Thanks for catching that for me. Divided by 12. We're going to close our parentheses. And then for our exponent, we're going to have n times t, 12 times 18. All right, I'm just going to double check, make sure everything looks right. 593, n is 12, n times t. Okay, so we hit our enter button, and we have the annuity will be worth 13,000. That was ugly. 13th, not much better. Come on, $13,326. And once we account for rounding, 31 cents. Now notice, this is our A value. And recall, back in the beginning, we said A represents what? That's right, our total future value, or it will be, or in the case of like a loan, it would represent our total repayment amount. But in both cases, it's the total. So the answer to part one of the question is 13,326.31. All right, so now what we need to find is how much interest will this have earned? Now that's a different question. So what we're talking about here is, let me lay this out for you. So would you agree with me that the total future value of this investment is going to be made up of two general components? The first part is going to be the principal that you invested. And the second part is going to be the interest the investment earns. Okay. So in order to answer part B of this question, we need to isolate that I variable. So the way we do that is we're just going to use our algebra rules. If I want to isolate I, well, I need to get rid of that P variable. And so what's going to happen is these will cancel out, and I'll be left with I equals our A value minus the principal. So in order to find the solution for part B of this question, we're going to simply take that 13,326.31, and we're going to subtract out the 45.95. So our 31 cents will just come down. This is going to be 1. Okay, we're going to have to make some change here. That'll be 3. That will be a 7. This will be 8. So after 18 years, this investment will have earned $8,731.31. All right. Moving on to our fourth and final exercise. Okay. Yadid's salary is $39,600 per year, and he gets a cost of living raise each year that is tied to inflation. Assuming inflation is constant at 2.92%, how many years will it take for him to reach a salary of $43,500? Okay, so what I want you to do now is pause the video, decide which formula we're going to use, and get all your variables set up. And I'll catch you on the other side of the break. Okay, so as I'm reading through this, I see this key word, inflation. So that tells me that I'm not going to be using simple interest. Neither am I going to be using compound interest. I'm going to be using our inflation formula. And our inflation formula is A equals P times the quantity, 1 plus R raised to the NT power. You might also see it written as A equals P times the quantity, 1 plus R, simply raised to the T power. The reason for this is when we're dealing with inflation, inflation is almost always calculated as being compounded annually. So unless your exercise specifically says otherwise, we are just going to understand and assume that n will always equal 1. So that's why we can safely omit it here, because anything times 1 is just going to give us back the original amount. It's not going to, that 1's not going to change anything. Pardon me. So our principal, we had 39,600. Our rate was 0.0292. Now for this one, this is actually all we need. So, and here's why. What we're going to do is we're simply going to run this calculation over and over again until we either meet or exceed our target value. So the easiest way to do this, the best way to do this is to build a chart. So we're going to call this years, and we're going to call this salary. All right. Now, the most overlooked part of this process, that if you miss this, it's going to throw you off into the weeds before you even get started. The most important part is to write down year number 1. That is going to be our starting amount. If you miss this step, you're done before you even get started. So now, this is going to be, this value, 39,600, is going to be the input for our P value. Okay. So what we'll do is we will run the calculation, 39,600 times the quantity, 1 plus 0.0292. We'll just run that in our calculator. So let's do this. We'll have 39,600 times the quantity, 1 plus 0.0292, and then we will close the parentheses, hit enter. All right. So after the second year, the income will be 40,756. In this case, we're not so concerned about the cents part, because we're not actually trying to hit a surgically precise target. We're just trying to either hit it or exceed it. Most of the time, you're going to exceed this. So that's why we're not horribly concerned about the percent. Okay, now this new value is now going to be the input for our expression for the next loop. Whoops. So we can come back over here and we can do 40,756 times the quantity, 1 plus 0.0292. Hit enter. And our third year is going to be 41,946. Then this will become the input for the next loop. So let's go ahead and do that. 41,946 times the quantity 1 plus 0.0292. And so our salary for year 4 is going to be 43,170. We haven't quite hit that 43.5 mark, but looking at the progression here, it's pretty certain that it's going to be 5 years. But just for sake of being thorough, let's just go ahead and do that calculation. And sure enough, we hit 44,430, which exceeds our target value. That's what we want. So how many years will it take for him to reach a salary of $43,500? It's going to take 5 years. All right. That wraps it up. Thanks for playing along. Don't forget to tip your waiter. I'll be here all week, and I hope this helps you. Talk soon.